as the question says, the work function of a photoelectric material is 4 electron volts, then what is the threshold wavelength? And find the wavelength of light for which the stopping potential is 2.5 volts. So we have been given phi, that is 4 electron volts, or we can say 4 into 1.6 into 10 to the power minus 19 joules, right? So proceeding with the first part, that is finding the threshold wavelength. Now work function is the energy which is the minimum requirement for the removal of the electron from the photoelectric material. Like the electron will simply come out without any kinetic energy, that is zero velocity, is due to the work function. And the lambda associated with that energy of the light wave is actually called threshold wavelength. So basically it is the maximum wavelength with which the electron can be emitted out of the photoelectric material. So we need to find the same. This energy, right now the kinetic energy is zero. This means this electron has been provided only with the work function of the material. This means that the energy that was associated with the light wave was just equal to the work function. So we can say that the energy is equals to phi for this light wave, which is also equals to hc by lambda, and we need to find the lambda only. So lambda is basically hc by phi. Putting the values over here, we get 6.63 into 10 to the power minus 34, that is h, into c, which is 3 into 10 to the power 8, upon phi, which is 4 into 1.6 into 10 to the power minus 19, giving us a value of 3.1 into 10 to the power minus 7 meters, that is approximately, or rather 310 nanometers. Now coming to the B part of this question, in which we need to find the wavelength of light for which the stopping potential is 2.5 volts. Now as the wavelength of this light wave reduces, the energy of this light wave increases, which means it has somehow overcome the work function of this material. So that that extra energy is supplied to this electron in the form of its kinetic energy actually. So we need to find that wavelength of light, then obviously it must be less than this threshold wavelength for which the stopping potential is 2.5 volts. Now if stopping potential is 2.5 volts, we know that if this electron is moving to the right with some kinetic energy and with some velocity obviously, then we apply, rather this is a negative charge, so we put it in an electric field so that the force in opposite direction is applied on this electron. So this is an electron, right? It is having a charge E. If we apply the voltage V, then it is retarded by the force EV, right? That is charge into the potential difference. And we need to find, we call this V to be the stopping potential. So what I can say from here is that 2.5 volts is applied, that is 2.5 electron volts